The ocean covers more than 70% of our planet, yet much of its depths remain unexplored. Among the most mysterious and extreme environments on Earth is the Mariana Trench, the deepest known part of the world's oceans. This vast, crescent-shaped abyss, located in the western Pacific Ocean, east of the Mariana Islands, reaches an astonishing 36,000 feet, 11,000 meters, at Challenger Deep. A point so deep that if Mount Everest were placed inside, its peak would still be over a mile, underwater. But what would it be like to take a journey to these depths? What creatures survive in such an extreme environment? How did this deep scar on the Earth's crust form? And how has human activity affected this seemingly unreachable world? Our journey starts at the surface, in the epipelagic zone, where light and warmth sustain an abundance of marine life. Here, coral reefs thrive, fish swarm in schools, and marine mammals like dolphins and orcas roam freely. At around 65 feet, 20 meters, shallow coral reefs flourish, while scuba divers can explore depths of up to 130 feet, 40 meters, before pressure makes further descent unsafe without specialized equipment. Whale sharks, the largest fish on Earth, glide through these waters at around 230 feet, 70 meters. While deeper down, at 330 feet, 100 meters, only professional divers equipped with sophisticated gear can safely navigate. At 490 feet, 150 meters, just 1% of sunlight reaches us. This marks the transition into the mesopelagic zone, or the twilight zone, where strange and elusive creatures begin to appear. The giant oarfish, a long ribbon-like fish reaching 36 feet, 11 meters, drifts through the water, inspiring myths of sea serpents. By 980 feet, 300 meters, we encounter Japanese spider crabs, with their 12-foot, 3.7-meter leg spans, the largest known arthropods in the world. At 1,640 feet, 500 meters, we leave behind the last of the blue whales, the largest animals to have ever lived. Deeper still, at 2,150 feet, 900 meters, the legendary giant squid lurks in the dark, its frisbee-sized eyes scanning for prey. Here, sperm whales dive in search of these enormous cephalopods, engaging in dramatic battles that have fueled maritime legends for centuries. By 3,600 feet, 100 meters, we reach West Mata, one of the world's deepest underwater volcanoes, last seen erupting in 2009. Descending further to 4,200 feet, 1,080 meters. Great white sharks patrol the darkness, relying on scent rather than sight to hunt. Leatherback turtles, the largest of all sea turtles, are also known to dive to this depth, possibly to evade predators or search for elusive jellyfish. At 6,000 feet, 1,800 meters, we enter the bathypelagic zone, or the midnight zone, where complete darkness reigns and the temperature hovers just above freezing. By 7,400 feet, 2,150 meters, we say goodbye to the deepest diving sperm whales, as no large vertebrate animals venture further. At 9,900 feet, 3,000 meters, deep-sea coral reefs flourish in total darkness, while by 12,100 feet, 3,700 meters, we reach the average depth of the world's oceans. But we are only halfway to our final destination. At 19,700 feet, 6,000 meters, we officially enter the Hadal zone, named after Hades, the Greek god of the underworld. The Mariana Trench begins here, a vast chasm in the Earth's crust formed by the slow-motion collision of tectonic plates. The Pacific Plate is being forced beneath the smaller Mariana Plate, creating this deep scar on the seafloor over millions of years. At 26,000 feet, 8,000 meters, we find the Mariana snailfish, the deepest living vertebrate ever recorded. Unlike fish in shallower waters, these creatures have evolved gelatinous bodies to withstand the immense pressure. Deeper still, we pass the world's deepest shipwrecks, such as the USS Johnston at 21,180 feet, 6,456 meters, and the Samuel B. Roberts at 22,621 feet, 6,980 meters, both sunk during World War II. At 35,153 feet, 10,935 meters, we finally arrive at Challenger Deep, the lowest known point of the ocean. The pressure here is 1,000 times greater than at sea level, the equivalent of having the weight of 50 jumbo jets pressing down on you. And yet, life still endures. Tiny amphipods, microbes, and xenophyophores, single-celled organisms the size of grapefruits, thrive in this otherworldly place. Despite its extreme remoteness and crushing pressure, the Mariana Trench has been explored by a select group of pioneers willing to push the limits of human endurance and technology. The first manned descent into the Challenger Deep, the trench's deepest known point, was achieved on January 23, 1960, by Swiss oceanographer Jacques Picard and U.S. Navy Lieutenant Don Walsh. Aboard the Trieste, a deep-diving research bathyscaphe developed by Picard's father, Auguste Picard, they embarked on a perilous journey that took nearly 5 hours to descend over 10,900 meters, 35,800 feet, into the abyss. Their mission shattered long-held scientific assumptions when they observed a flatfish and shrimp-like creatures thriving in a place once believed to be devoid of life due to immense pressure and complete darkness. More than 5 decades later, in 2012, filmmaker and explorer James Cameron made history with the first solo dive into the Challenger Deep, piloting the Deep-Sea Challenger, a state-of-the-art submersible built to withstand the trench's extreme conditions. Cameron descended in just under 2.5 hours. Unlike the grainy footage captured during the Trieste mission, Cameron's high-resolution cameras documented the otherworldly landscape in unprecedented detail, revealing bizarre, translucent creatures and previously unseen geological formations. His mission not only contributed valuable scientific data, but also reinvigorated public interest in deep-sea exploration. Since then, technological advancements have enabled a new era of exploration in the trench. Numerous unmanned submersibles and robotic probes, such as those deployed by China's Fenduji and the United States Deep Discoverer, have continued to map its depths, uncovering new extremophils, organisms adapted to high-pressure environments, as well as hydrothermal vents and other deep-sea geological features. These discoveries continue to challenge our understanding of life's resilience and the dynamics of Earth's deepest environments. One might assume that the Mariana Trench, being so deep and remote, would be untouched by human influence. Sadly, this is not the case. Expeditions have discovered plastic waste at the very bottom, including plastic bags and microplastics embedded in deep-sea organisms. This startling find proves that pollution has reached even the most inaccessible corners of our planet. Additionally, the growing interest in deep-sea mining poses another threat. Extracting minerals from the ocean floor could irreversibly disrupt fragile ecosystems that have existed undisturbed for millions of years. Despite these formidable challenges, the Mariana Trench remains an invaluable scientific goldmine, offering a glimpse into one of Earth's last great frontiers. Cutting-edge robotic technologies, AI-driven data analysis, and advanced sonar mapping are transforming the way we explore the Hadal Zone, the deepest parts of the ocean. Unmanned autonomous vehicles and remotely operated vehicles can now navigate the crushing depths with increasing precision, capturing high-resolution imagery, collecting biological samples, and mapping the trench's complex topography with unprecedented detail. These advancements are revealing not only new species but also intricate geological formations, including vast fields of hydrothermal vents and towering mud volcanoes that provide insight into the geological activity shaping the ocean floor. One of the most exciting prospects of deep-sea exploration lies in the potential for groundbreaking biotechnological discoveries. Extremophilic bacteria thriving in these high-pressure, low-temperature environments have already demonstrated unique metabolic processes that could revolutionize medicine. Some deep-sea microbes produce novel enzymes and bioactive compounds that may lead to the development of next-generation antibiotics, crucial in the fight against antibiotic-resistant bacteria. Additionally, certain marine organisms found in deep trenches produce compounds with anti-cancer properties, opening the door to innovative cancer treatments inspired by nature's own biochemical adaptations. Beyond earthly applications, the life forms discovered in the trench could also offer profound insights into the possibility of extraterrestrial life. The extreme conditions of the Challenger Deep, cold, darkness, and intense pressure, are strikingly similar to the environments found beneath the icy crusts of Jupiter's moon Europa and Saturn's moon Enceladus. These alien oceans, concealed beneath thick layers of ice, may harbor microbial life sustained by hydrothermal vents, much like those found in Earth's deepest trenches. By studying how organisms survive in such inhospitable conditions here on Earth, scientists gain crucial knowledge that could guide future astrobiological missions, shaping our search for life beyond our planet. The Mariana Trench stands as one of Earth's last great frontiers, an abyss where science, mystery, and exploration intertwine. From its sunlit coral reefs to the crushing Hadal depths, every layer of this vast oceanic realm tells a story of evolution, survival, and adaptation. Yet, as we continue to unveil its secrets, we must also recognize our responsibility to protect it. This trench is more than just a remote point on a map. It is a living testament to the resilience of life and a stark reminder of how much remains undiscovered in our own world. But the greatest question still lingers. What other mysteries lie hidden in the abyss, waiting to be revealed? If you enjoyed this journey into the deep, don't forget to like this video and subscribe for more mind-expanding explorations. Who knows? The next great discovery might be closer than we think.